In this video, we're going to look at one special type of partial fractions that come up on the A-level further maths syllabus, but don't come up on the single maths syllabus. And that's ones where one of our factors in our denominator is an irreducible quadratic. So if you look at the example here, on our denominator, we've got x squared plus 7 times x subtract 4. And that x squared plus 7 doesn't factorise, at least if we're not using complex numbers, and we're going to stay clear of those for now. So if it did factorise, we'd get distinct factors, we'd split it up as per normal single maths A-level. If you've not seen that video and you want to see the other partial fractions, that's in the single maths playlist. But in this situation, well, what can we do? It makes sense if we're splitting this up and we can't do anything about the factor, that our two fractions, one will have a denominator of x squared plus 7, and the other one will have a denominator of x subtract 4. That's completely right. That's not a complication here. Now, on the top, the natural first thing to try, if you've not seen this before, is just to try a over x squared plus 7 plus b over x subtract 4. If you go for that, you will run into difficulties. If you think about trying to compare coefficients, you've got two variables and you'll end up having to compare coefficients for x squared, x and the constant. You've got two variables to solve three simultaneous equations. Most of the time, that will be impossible to solve for most situations. So that's going to run into a difficulty. The solution for this is on our first fraction over x squared plus 7 over our quadratic, rather than just going for a constant, try a linear factor, ax plus b over that quadratic, and then over our other one is going to be a simple c over x subtract 4 here. So that's the only extra complication. Now we just need to work through here. So if we're going for this, rework this so we get the same denominator as the left-hand side. So we want x squared plus 7 times x subtract 4. So we're multiplying top and bottom of our first fraction by x subtract 4. We're multiplying top and bottom of our second fraction by x squared plus 7. We now have the same denominators on both the left-hand side and the right-hand side. So we want the numerators to be the same. It's now easier for us to compare those. So let's write that down. That means we want 5x squared subtract 13x plus 18 to be identically equivalent to ax plus b times x subtract 4 plus c times x squared plus 7. We're trying to find the values of a, b, and c so that these two things are identically equivalent here. You can do this by comparing coefficients. You can compare your coefficients of x squared, of x and your constants. You'll get three simultaneous equations in three variables. They will solve, but there's plenty of room to make a mistake. You've got to do the expansion, you've got to get your simultaneous equations, and then you've got three simultaneous equations in three variables. Substitution should make your life easier here, even though we're going to finally run into points where we've not got clever substitutions anymore. We do definitely have one clever substitution to make, and that's x equals 4. If we substitute an x equals 4 in this case, that first term on the right-hand side will disappear entirely because we've got 4 subtract 4, and that's all go. So if we submit x equals 4 to both sides, on the left-hand side we go 5 times 16. I'm going to get my calculator out here. So 5 times 16, then subtract 13 times 4 plus 18. On the left-hand side, you're getting 46. And on the right-hand side, you're getting the whole first term disappears because of that x minus 4 goes away. So you're just left with plus c times x squared plus 7. So 16 plus 7 is just 23. So we get 46 equals 23c, divided both sides by 23. C equals 2. Excellent. Nice and easy. We've got one in the bag. At this point, it looks like we don't have any more clever substitutions because there's no value of x we can sub in to make the x squared plus 7 disappear. However, substitution x equals 0, we should see actually makes our life very easy indeed. If we substitute x equals 0, firstly, left-hand side's nice and easy to deal with. We just get 18. And on the right-hand side here, that ax just disappears because we've got a times 0, and we just end up with b times negative 4. So we get negative 4b, but then we still have that plus 7c, but we know what c is. We know c is 2, so we can whack that in. So 18 equals negative 4b plus 14. Add 4b to both sides, subtract 4, so we get 4b equals negative 4, and b is equal to negative 1. Sorry, that looks like a d there. B is equal to negative 1. So we've got our value of b, we've got our value of c, we're left needing our value of a. At this point, you could compare coefficients if you want, because you've got two of your constants. It's going to be fairly nice to get the third, but that'll still need us to expand. Let's just make another substitution. At this point, there's not a really clever thing we can do, but let's keep it as simple as we can. Let's go for x equals 1. So on the left-hand side, 5 subtract 13 plus 18. Well, that's going to give us 23 subtract 13, which is 10. And on the right-hand side, we've got, well, x subtract 4 is going to be negative 5. So it's negative 5 lots of ax, which is just a plus b, and then plus 8c. We get this. Time to put in our values of b and c. Well, we can expand first even potentially. So negative 5a subtract 5b plus 8c. And now if we sub in, so we've got negative 5a minus 5b. If b is negative 1, that's plus 5, and plus 8c is plus 16. And now we're ready to solve. So add 5a to both sides, subtract 10, and you're just going to get 5a equals 21 subtract 10 is 11. Something's gone wrong for me here. I don't know if you can spell your mistake faster, the mistake faster than I can. Oh, sorry. There's the mistake. I'm not going to worry about re-recording this one. We'll go through it together. X subtract 4 should have been negative 3 there. So let's just make that correction. So we're going to get that this is minus 3. So minus 3a minus 3b plus 8c. There you go. Even the best can make mistakes sometimes on those. So now we're subbing in and we're getting minus 3a plus 3 plus 16. That's more encouraging. We'll end up with 3a is equal to 9 and a is equal to 3. So our final answer, going back to the top and substituting in, we're just getting that it's 3x subtract 1 over x squared plus 7 plus 2 over x subtract 4. Sorry about a little mistake there. Hopefully it didn't confuse matters too much. Hope that was useful. Thank you very much.